Welcome to Pomodoro Joe for Tuesday, April 11th, 2023. Today we're doing LeetCode problem 2390, remove stars from a string. It's a medium problem. All right, so in this problem, we're given a string that has some stars or asterisks in them. Asterisks? We're given an input string with some stars in the middle. Now we need to remove all the stars from the input string, but we can only do it in this particular fashion. We have to choose a star, we remove the closest non-star character to its left, and then we can remove the star. So in this case, we choose a star, and we might choose this star. We can remove the T, and then we can remove that star. Then we can remove this star, but we have to remove the E first, then we can remove the star. All right. So with that, we'll put 25 minutes on the Pomodoro timer and get started. All right, this looks like it's going to be a fun one. So here's the plan. We'll go through every character in the input string, character by character. As soon as we get to a star, then we know we have to remove the previous non-star character. So we have to keep track of what our previous characters were. All right, now anytime you have to keep track of something and you have to remove the last, like keep track of the last thing, then you're going to want to use a stack. So this is true if you're traversing a graph and you have to keep track of the last node you visited. This is true if you're traversing a string and you have to keep track of the last character you're at. You'll want to use a stack. So we will use a stack. So we'll have a stack, and in Python, you implement a stack just by using an empty list. Now a stack has two operations. We have a push and a pop. With the list, we will do an append, which is the same as a push, and we will do a pop at -1, meaning pop the last element off our stack. So we'll just go through. As we find characters, we'll push them onto the stack. If we hit a star, then we will just pop the last character off the stack because we're throwing that character away. And we'll keep going until we reach the end of our string. Then at the very end, we'll have to convert our stack back into a string, but that's pretty easy to do using the join operation. So we will just do this for every character in our string. If the character is equal to the star, then we'll just pop the last element off our stack and keep going. Otherwise, we're just going to push this character onto our stack. Now at the very end, we do need to convert our stack back into a string, but that's easy. You just take an empty string and you call join, and you pass in your list, which is a stack in this case. All right, so this should be it. Let's check it out. Let's see if C is equal to this, stack.pop, and I don't need a colon. All right, try this again. All right, that works. Let's submit that and see how we do. We do all right. We pass, and we beat 63% for runtime and 40% for memory. So that is not too bad for our first try. All right, so this is our basic algorithm here. One thing we can do to maybe speed this up a little bit, we can play around with maybe making our push onto the stack the default and only pop later. Basically, we're just going to switch the order of these. So we'll say if it is not a star, then we'll append. And if it is a star, then we'll pop. I know this doesn't seem like it'll make much difference, but sometimes it can make a huge difference. So I don't know if this will make things better or worse, but hopefully it'll make things better. All right, still works. Let's see if this makes our runtime any better. Not really. Makes a little bit of a difference, and it actually decreases our runtime. So, sorry, it decreases the runtime performance. So we're going to put this back. All right, couple things we can do still. One simple thing, let's convert this stack from being a list to being a deck. Now a deck is really just a list, but it's an optimized version of a list that's really good at pushing and popping. So it's great for things like queues and stacks. So we will use a deck, and that's D-E-Q-U-E. Now the deck is in the collections library. In LeetCode, you don't need to import it, it's just there. But in general, if you're writing your code in Python, you might need to import the collections library to get your deck. All right, so our stack will be a deck, and instead of doing a pop -1, we do a pop with no arguments. So by default, the deck will have a pop operation, and it will just pop the last thing off the list. And it still uses the same append, so we're all good here. All right, I need to go back to this point. So if you do have a star, then we'll pop off our stack. If we don't have a star, we'll just append our character. All right, let's try that. Still works. Let's see if this gives us any improvement. And it does. It crushes it. We're at 90% for runtime and 14% for memory. So the deck makes a huge difference. Now, if we want to get any even slight minor improvements to this algorithm, we might need to change our names here. So I'm going to call this R for result. Instead of using stack, we'll use the character R. We'll still have to do pop and append. There's nothing else that we can do to save here. So let's try this and see if it gives us any improvements. And it doesn't. So that surprises me. Usually that makes a difference. So we have our deck, we have for every character, we'll go through. I could try swapping these around again. Maybe it'll make a difference this time. Probably not. Another thing we could do is, no, I don't want to do that. You could always push the character on and then do 2 pops if you have a star, but I don't want to do that either. All right, we could try this. We could do a continue and then have the default just be, hey, we're going to push this character on. All right, see if we can make any gains. I really want to get higher than the 90%. 95.16% for runtime and 77% for memory. So that is a huge win. All right, now this code, because it's so simple, it's pretty easy to understand. I don't feel too bad about writing this code. It might not be the cleanest, and things like having R as your result, probably not the best name. But this is such a simple little program or a simple little function, I'm not going to worry too much about it. All right, that is it for me. 95% runtime, 77% memory. See if you can beat that. Try this one on your own. Hope you enjoyed this. Hope you learned something. Hope you had fun. Hope you can go out and write better code.